Circle theorems define relationship between circles and its parts like arcs, angles, chords, tangents. So before we move on to see the theorem, we need to know the terms associated with circles. So if there is this circle with a center, now a circle is any closed region in which the distance from the center to a point on its circumference is always same. Here I'm talking about the radius. So a radius in a particular circle has equal length. So any radius in this circle will be of the same length. And this boundary or the outline is called as the circumference of the circle. If I double the radius so that it joins a point, so it connects the point on the other side of the circumference, that's the diameter. If I join any 2 points on the circumference of a circle, that's the chord of a circle. A chord divides a circle into segments. So here we have so if I shade this part, that's a segment of a circle. To be more precise, this is the minor segment. And the other side of the chord, everything outside this region is the major segment. If I take a portion of a circumference, suppose this part, that's the arc of a circle. And if I find the region enclosed by the arc and the radii, so this shaded region is the sector of a circle. Or this is the minor sector, and the region outside this minor sector is the major sector. And then we have the tangent of a circle. So a tangent is a line which touches the circle at only one point. So this is the tangent. So with this information, let's move on to see the first circle theorem. So here is a circle with a center C, and AB is the chord of a circle. So the line which connects the chord at 90 degrees, or the perpendicular drawn from the center to the chord, bisects the chord. So here we need to know the word bisect. It means cuts in equal parts. So it cuts in equal parts, or makes it in 2 equal halves. So the perpendicular from the center cuts the chord in 2 equal parts. So this AD, the length of AD is equal to the length of DB. So AD equals DB. The keyword here is this line CE has to be the perpendicular line. And AB has to be the chord of the circle. So the line which is perpendicular to the chord of the circle bisects the chord, or makes it into equal parts. The next one is the angle in a semicircle. So a semicircle is formed by the diameter of a circle. So the diameter cuts the circle into 2 equal parts. So each one of them is like the semicircle of a circle. So here AB is the diameter of a circle. And the angle opposite to this diameter, that is the angle C, is 90 degrees. And this angle, or this vertex of the triangle ABC, should touch the circumference of the circle. So it should the angle should touches the circumference. Or to be precise, the angle which is opposite the diameter, the angle opposite to diameter should touch the circumference of a circle. So one of the side of the triangle has to be the diameter, and the angle or the vertex opposite to the diameter should touch the circumference. Then that angle is 90 degrees. It should satisfy both these conditions so that this property holds true. The next one is the angle at the center and the relation between the angle at the center and the angle at the circumference. So before that, we need to understand one thing. We need to know the word subtends. Now, we often come across the word subtends when we are talking about circle theorems. So let me quickly tell you what do we mean by the word subtend. Subtend means make or create an angle. So if I am talking about the arc AC, it's making this angle theta at the point B. So here I say the arc AC subtends the angle at the point B. Similarly, this arc AC is subtending the angle theta at the point B here. So that's what we mean by the term subtends. So when I'm talking about this circle theorem, here I'm saying that the arc AC subtending an angle at the center, and the same arc AC subtends an angle at the circumference. The relationship between these two angles is the angle at the center is double the angle at the circumference, or the angle at the circumference is half the angle at center. So to remember this theorem, you need to know certain keywords. So one of them is it should be subtended by, the angles must be subtended by same arc, the arc AC. Or we can also talk about the chord AC. So if I join these 2 points to make a chord, then I can say this angle is subtended by the chord AC. So the angle at the center and the angle at the circumference. So what is important here? Here the angles should be subtended by the same chord. Both these angles should be from the same arc or the same chord. And one of them has to be at the center and the other angle should be subtended at the circumference. It should touch the circumference of the circle. So if it satisfies all these 3 conditions, then this property holds true. The next is same segment theorem. So here I'm talking about the same segment. Here we see the chord DB is subtending an angle here at the point C, and the same chord DB is subtending another angle at the circumference. Then these 2 angles will be of same size. So here it should be angles should be subtended by same chord. Or I can say the arc as well, the arc DB. So I can use chord or arc here interchangeably. And the angles, the angles they are subtending must touch the circumference of the circle. So angles, both angles to be more precise, both angles must be on circumference. Then these 2 angles are of same size. So for this property to hold true, they must satisfy these 2 conditions. The angles must be subtended by the same arc or same chord, and both the angles must be on the circumference of the circle. All right, next property is about the cyclic quadrilateral. Now we know what a quadrilateral is. Any 4-sided polygon is a quadrilateral. So any 4-sided polygon inside a circle so that each of its vertex is on the circumference, then it's a cyclic quadrilateral. So for a quadrilateral to become cyclic, it has to touch the circumference of the circle. Each of its vertex must be on the circumference. Now what's the property here? It says that the opposite angles are supplementary. They add up to 180 degrees. So here the opposite angle, the angle opposite to A is C. So these 2 are opposite angles and these 2 are opposite angles. So the sum of A and C is 180. B and D add up to supplementary also. So add up to make a supplementary pair of angles. So that's a cyclic quadrilateral. Well, this is a very straightforward theorem where we just have to see it has to be a cyclic quadrilateral. You need to know what we mean by the word cyclic. And then we need to know that the opposite angles add up to 180 degrees. The next is the alternate segment theorem. Now here there are a lot of keywords we need to remember. Well, here there is this, what does the theorem say? First, let's see that. So the tangent, the angle between the tangent and a chord is equal to the angle subtended by the same chord on the circumference of a circle. So let me repeat here. The angle between the tangent and a chord of a circle is equal to the angle subtended by the same chord on the circumference of the circle. So here we need to know the angle between tangent and chord. That's the first thing. It subtends, so this angle is equal to the angle subtended by the same chord, subtended by same chord on circumference. So this point should be on the circumference. Then this angle and this angle will be equal. So to demonstrate you, let me show you another example here. So let me use this color green. Okay. So we see this tangent has, and there's another chord AB, right? So the angle between this tangent and the chord AB will be equal to the angle subtended by the same chord AB on the other side of this, so here on the circumference of the circle. So this angle is subtended by the chord AB. So this angle will be equal to this angle. So if this is suppose x, this will also be the same angle x. So I hope I try to simplify this theorem as much as I can. So it's the keywords here are the angle should be between the tangent and the chord, and the angle is subtended by the same chord on the circumference of the circle. So this the other part of the angle should touch the circumference. So it needs to satisfy these things so that the property holds true. All right, moving on to the next theorem. This is considerably straightforward and easy theorem, where it says the angle between the tangent and the circle is 90 degrees, or the radius touches the tangent of a circle at 90 degrees. The tangent plus radius, that they are meeting their meeting point, or the intersection. Intersection is where they meet. So the point of intersection of the tangent and the radius is 90 degrees. So for this property to hold, one of the line has to be tangent, other has to be the radius of the circle, then this angle is 90. It can be radius, it can be diameter as well, because we can extend the radius to make it as a diameter. Nothing will change here. So it will be still 90 degrees. Next theorem says, if there is an external point A and you're drawing tangents from these external point to the circle, then the distance of these two tangents will be same. Or to be precise, the length of the tangent from the external point A to the point of contact of the tangent. This point D is the point of contact of tangent to the circle. So where the tangent is touching the circle. So this point, from A to this point D, this distance is equal to the point A, to the distance from point A to the point B. So here AD equals AB. Here AD and AB are tangents to the circle. And these points are the point of contact of the tangent with the circle. Then these two lines will be of equal length. We use this theorem when we are trying to figure out if the triangles, like if you divide this and make into two triangles, then we show that they are both congruent triangles. So anyways, we are not going into that part. It's just the theorem which says that the tangents from an external point has equal lengths. So I hope this covers all the circle theorems, and I try to make it as simple as I can. Thank you for watching my video, and make sure you subscribe and share my videos, like and comment, and give your suggestions. Thank you so much.